In talking about sets, we often want to do operations with sets. And to do operations with sets, we need a little bit more vocabulary. First, we're going to talk about this thing called the universal set. It is the set of all the elements under consideration. So if we're only working with numbers that are less than 100, the universal set is all the numbers from 1 to 100. The empty set is a set that contains 0 elements. So if we put it in the squiggly brackets, it's going to have nothing in the squiggly brackets. It's often abbreviated, though, with a circle with a slash through it, meaning the empty set. Now, when we're interested in combining two sets together, if we're talking about the students in statistics and the students in calculus, and we want all the math students, we're going to combine those students together. That is the union of two sets. It is when any element of A or any element of B or both can be considered. When we want to combine sets A and B together, we'll write A with this U. It's kind of like a horseshoe pointing up. B. The horseshoe pointing up means A union B. We're going to combine A and B together to be one larger superset of both of them. Now, oftentimes we're not interested in just combining the sets, but we want to know what the sets have in common. If we want to know days of the week that I work and days of the week when it rained, we want to know how often I was working when it was raining. That is the intersection of two sets. When we want the intersection of two sets, A and B, it's a set that contains any element of A and any element of B. In that case, we're going to write A and the horseshoe's upside down now. A intersect B. Other times we're interested in what's not part of the set. If we're talking about all the numbers from 1 to 10, and we're talking about the even numbers, the numbers that are not even are the odd numbers. So the complement is sometimes of interest to us. And so we want the complement of A. We're going to write A with the little c as a superscript next to it. That means A complement. Now, oftentimes to help us get an idea of how things are connected and related to each other, when they overlap and when they don't, we're going to write a Venn diagram, which is a graph of shapes to help us visualize the interaction between sets. And we're going to take a look at what that looks like here in an example. To set up our examples, we're going to use the universal set, which is going to be the numbers from 1 to 10. All the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the universal set. When we're talking about A, that's going to be the set of the even numbers. So the even numbers, 2, 4, 6, 8, 10. Obviously 1 through 10, because the universal set that we can choose from is only the numbers 1 through 10. When we're talking about set B is going to be the multiples of 3. Obviously from 1 to 10, because that's the universal set. So multiples of 3, 3, 6, 9. And finally, we'll have set C. That's going to be the prime numbers. Obviously, again, 1 through 10, because that's our universal set that we can choose from. So prime numbers, 2, 3, 5, 7, numbers that can only be divided by 1 and itself. So if I wanted to make a Venn diagram, how we're going to draw the Venn diagram is we're going to have a big rectangle to represent the universal set S, the numbers 1 through 10. Then we're going to have overlapping circles to represent sets A, sets B, and set C. So A is the even numbers. B is the multiples of 3. And C is the prime numbers. And so if I think about the numbers, think about the number 1. 1 is not prime. It's not a multiple of 3. It's not even, so it's not going to be in any of the circles. 2, the number 2 is even, and it's prime. So it's going to go where even and prime overlap, but not overlapping with a multiple of 3. 3 is a multiple of 3, and it's prime. So it goes where those overlap. 4 is even, but not prime, and not a multiple of 3. So it just goes in the even section. 5 is prime, not a multiple of 3, and not even. So it goes in the prime section. 6 is a multiple of 3, and it's even. 7 is prime, but not a multiple of 3, and not even. 8 is even. It's not a multiple of 3, and it's not prime. 9 is a multiple of 3 that's not even, and it's not prime. And 10 is even, but not prime, and not a multiple of 3. So this kind of organizes where each of the numbers go. And you can see where they sometimes overlap, sometimes they don't. And that can help us answer questions like, what is A union B? In other words, if we combine all of A and B together, that's all the numbers in A and all the numbers in B. That's all of these numbers together. So sometimes it helps to define clearly what is A. A is the even numbers. That's 2, 4, 6, 8, and 10. What's B? B is the multiples of 3. That's 3, 6, 9. So if we want A union B, that's going to be all the elements of A, 2, 4, 6, 8, and 10. And the elements of B, 3. Now, we're not going to list 6 again because 6 is already right here. But the number 9 needs to be added. So we don't want to repeat numbers in our sets. So A union B is 2, 4, 6, 8, 10, 3, and 9. You might want to put them in number order, but that is A union B. What is A complement? Now, if I want A complement, that's asking for everything that's outside of A. So all the numbers that are not part of A, all of those are going to be part of A complement. And so again, it's going to be helpful to remember that A is the even numbers, 2, 4, 6, 8, and 10. So then for our answer, A complement is all the numbers that are not in this list, which is 1, 3, 5, 7, and 9. Let's try another one. Let's do A intersect B intersect C. In other words, what numbers are in all 3 sets? Where do A, B, and C overlap? They're going to overlap right here in the middle. And you notice in the middle, there are no numbers that are even and a multiple of 3 and are prime. There's no numbers that fall into that. So since there's no numbers that fall into both of them, we're going to say it is the empty set, which is the 0 with a slash through it. Or you can just put the brackets with nothing in it. Let's do one more. Let's do B complement intersecting with C. Okay, it might be helpful to remind ourselves, what is B complement? Well, B complement is everything that's not in B. So if B is the multiples of 3, the numbers that are not multiples of 3 are 1, 2, 4, 5, 7, 8, and 10. And then let's compare that with C. C's the prime numbers. The prime numbers are 2, 3, 5, and 7. So in other words, we're looking for on our graph B complement. That's everything outside of B. And we want to know where that overlaps with C. What are the numbers in common to both groups? Well, we can see that B and C, B complement and C, B complement and C overlap on the numbers 2, 5, and 7. 2, 5, and 7 are in both. One more quick notational thing that I want to squeeze in right at the end of this video is sometimes we're interested in the number of things that are in maybe B complement intersects C, for example. When I put that little n in front, that little n means I just want to know how many things are in there. And we see that there are, just counting from the problem we just did, 1, 2, 3 numbers that are in B complement and C. So the size of B complement intersects C is 3. So the little n just means how many things are in that set. All right, it's your turn to practice some of this set theory. Take a look at the questions, take a look at the assignment, and let your instructor know if you have any questions.